All right, well, let's go ahead and get started on this then. So if you guys saw from Facebook or from that engineering email, today we're going to be teaching LaTeX. Some of you may have seen it before, but for those who are not familiar with it, what exactly is LaTeX? If you look it up online, one definition of what LaTeX might be is a document preparation system, which is really just a fancy name for something that helps you make documents, right? Like Microsoft Word or Apple Pages or, I don't know, LibreOffice on Linux. But it's different from Microsoft Word because, for example, in Word, if you want to write a document, you see this page in front of you, right? You just type stuff into it and you see your document. LaTeX works a little differently. It's technically a markup language. So the most famous markup language is probably HTML, which you've probably all heard of. And a markup language basically is something that puts content on your screen. You have text on there. But the markup language comes in when you have some sort of programming, these little tags and other bits of language that help modify your code, modify your type on the screen. So you'll see in a bit what I mean by that. With LaTeX, if you look at your code, quote unquote, you'll see your document and there will be these little tags that sort of modify how it looks. So when I tell my friends this, they're going to be like, so LaTeX is actually a language? I need to do coding to make my document now? Are you crazy? You kind of do, but it's not that bad. And we'll see in a bit. LaTeX is great, but one of its big downfalls is that there is a big learning curve when you first start off. As you see, when you first start off, there's a huge bump in difficulty. You have to learn how to use it first. But once you get over that hump, hopefully, which is where this workshop comes in, everything else is much easier. If any of you have learned the programming language before, it's the same way. There's a lot of friction when you first start off learning that language, right? But once you become familiar with the language, it's super easy to keep learning new things. You just look up libraries, look at documentation, figure out how it works. And it's easy, once you get past that initial hump of difficulty, to keep teaching yourself how to use LaTeX. And hopefully this workshop will take you past that initial hump, and then you'll be able to teach yourself LaTeX from here. So we're all engineers here, right? Why should I, as an engineer, use LaTeX? And there are a few reasons. First of all, LaTeX is powerful. It's very powerful. Again, as we'll see throughout this workshop. One of the big things is that if you guys have ever written a long paper in Word, let's say you have a lot of citations at the end, a lot of figures, a lot of equations, they're all labeled, right? You have equation 1, equation 2, citation 1, citation 2. If you want to insert a citation in the middle of your bibliography, like let's say I have 20 citations and I want to add a new number 10, then what I have to do is I have to shift all those numbers by myself, right? And that's going to be a big pain. The newest version of Word has something that kind of does that for you, but it's still very clunky. LaTeX will do all this for you. If you add a new equation, a new figure in the middle, it'll do all the shifting for you. It'll do all the references for you, and you'll see more later. It's also free, which is a big, big advantage. You may have seen in the email that you could have downloaded it on your laptops if you wanted. You can follow along on your laptops, completely free. And it's also pretty. It makes these really pretty documents. And let's look at some examples of that. So this is a document that was made in LaTeX. We're actually not going to learn how to do this. This is, I believe, JavaScript embedded inside a LaTeX document. And don't worry too much about the details. This is the Lorentz attractor. It's these 3 differential equations. If you kind of track those differential equations, you end up with something that looks like this. It doesn't matter. What is cool is right here. This complex 3-dimensional structure of this attractor is hard to see in a 2-dimensional plot. Therefore, click on the image to start, stop, slow rotation. So we click on it, and the image rotates inside your PDF. Just moving stuff inside your PDF. That's pretty cool, right? We're actually not going to learn how to do that today, but it's pretty easy to learn. Sorry. LaTeX is also pretty professional. This is a real paper that has been submitted to a journal and published, and is written completely in LaTeX. You'll notice as we look at more of these example papers that LaTeX has a very distinctive look to it. Some of you might have seen this look before. Chances are your math professors might have written your homework in LaTeX before. So it's professional, and actual journals actually do use it if you plan to submit a paper to a journal. that's not what I want. One of the big pluses of LaTeX is that it's especially popular with the math and physics people. It's starting to get more popular with engineering, and I'd like to get really popular, but right now it's really popular with the math and physics people. And this is one of the main reasons why. It makes very professional looking math, and it's a lot easier to type once you get used to it than Microsoft Equation. Microsoft Equation can be a big pain once you get bigger and bigger equations. LaTeX, it's technically coding, but it's a lot easier to think of, at least once you get used to it. So you see basically a math paper here, and there's a lot of cool stuff. For example, right here, this references equation 5, and it looks like a hyperlink. So if I click on it, oh, reference 5, it'll take me to reference 5. If I want to go back, this tells me that reference 5 is on page 2. I click on this, it takes me back to page 2. Let's see, theorem 0.1, looks like it's highlighted. It takes me to theorem 0.1. That's hyperlinks inside the PDF, and that's something you will learn how to do today. Makes your PDF look pretty professional, pretty handy to navigate. And so that's LaTeX in a nutshell. It makes these really professional documents, very pretty documents, easy to navigate, and it's easy to use once you get past that initial hump of difficulty. So enough about that, let's just get started. Under Start, go to All Programs, and look for Win Edit 6, and open it. Oops. Go ahead and make a new one. So up here, make a new document, click this guy, and then let's go ahead and save that somewhere. I'm just going to make a folder on the desktop. And name it something, I don't know, my documents. Has everyone created a LaTeX document? Once in a while, so this is going to be a workshop, right? You guys are going to be working, following along. Once in a while, I'm going to stop in the middle of the lecture, walk around, make sure everyone's on the same track. Feel free to raise your hand at any time, of course, if you have any questions. But yeah, don't worry if I get ahead. I will stop at random points in the lecture to go around and make sure everyone's okay. So we all have a document, create a new document, named it, saved it. So LaTeX works in two ways. Right here, this is your main document, right? This is where you would type all your content. In LaTeX, there are two big tags, I guess, the bread and butter of editing your text. There are commands, which looks something like this. Backslash, command, and then inside curly brackets, left curly bracket, right curly bracket, whatever your argument is. That's generally how a command works. So for example, if I wanted to write something in bold, if I wanted, I don't know, in bold to be in bold, the command for that is text BF. And I would put whatever words I want in bold inside those curly braces. In addition to single commands, there are also environments, and they look something like this. There's always a begin, and then whatever your environment name is. Whoops. And then an end. Environment.
Question.
Yes?
Are you going to be using the bottom window?
The bottom window just tells you, it's kind of like an output log when you compile. It helps to have just a little bit showing.
Okay, do you mind enlarging font?
You want this larger?
Yeah.
Okay. Oh geez, is that how this works? Well, let's see if this works. Set it to 12. Oh, so that is how it works. 14? Is that changing it at all?
No.
No?
I think you have to save it, right?
Yeah, it's saved. Sorry, I've actually never tried changing the font size on this. Well, maybe I have to restart it. Nope, that didn't change it. Sorry, is it a big pain for you guys in the back to see? Okay, well, I also have a spare laptop if any of you, or if you have your own laptops, feel free to move up. So, in addition to commands, we have environments. So command was just backslash command and then your argument in curly brackets. Environments, there's always a begin and an end. And then whatever your environment will be, you put inside those curly brackets. So this actually doesn't work because boldface isn't an environment, but I'm going to use that as an example anyway. So if I want a whole paragraph to be in bold, I would use begin. And then my environment will be bold. So text BF, that's the name for it. And then end text BF. And then everything I write inside this environment will be in bold. So environments can be helpful if you have a really long command that you want to use. And we'll see other uses for them later. So just as a quick refresher, because these two are the bread and butter of how you edit your text. There are commands. It looks like command and then argument. It's usually helpful for just, I don't know, a few strings of words or a single word. And there's an example. Text IT is the command for italics, and text BF is the command for bold font. And there's environments, the other one. Begin, something, end, something. And this would be another example, text BF. And why would we want to make a whole paragraph bold? I don't know, but this is how you would do it. So if you wanted to use an environment for a long string of text, that's how you would do it. Begin, something, end, something. Those two, again, are the bread and butter, and we will use them a lot when we make our document. So speaking of commands, let's go ahead and erase all of this. The first command that you will write in your document is something called the document class. Backslash document class, and then curly brackets. The document class basically tells the LaTeX compiler what sort of document you're writing. There's different kinds. There's articles, letters, I don't remember, there's, I don't know, resume. The most popular class by far is article. And if you want to look up what the other document classes are, you can easily find them online. What this tells the compiler is that this document class is an article. And because of that, the compiler will create certain guidelines based off of this. It'll create these margins, it'll create these certain rules. You can change them later, but the article basically creates this template for you to start on. So that's the first command you will ever write. The first environment you will ever write, begin, is your document itself. Your document is an environment. So now you can write all your stuff in here. This is my first LaTeX document. And now if we actually turn this into a PDF, it will work. So if any of you have programmed before, you don't create your program on the fly, right? Usually what happens is you write your code, and then you do something. You compile your code, and that code turns into an output. Usually in most cases it's in the program. In this case, your output is a document. So this text editor, WinEdit, will take your code, your document, and compile it into a PDF. So to compile this code, click this button here, or the shortcut is Control-Shift-P. It should read your code and compile it, and your output is a PDF. Does everyone get something like this? Any problems? Everyone good? Yeah, what's up?
Mine just, the progress thing just, also, can you do comments in LaTeX? Like, you know, another one would be,
Yeah.
Does that,
It's the percent sign.
yeah, isn't that right?
Oh, you have to end your document.
Oh.
So to stop compiling, Control-C. I think it should kill the process. Try clicking this window. Control-C. Yeah. Try recompiling. any problems?
Wait, how do you terminate it?
Click on the window at the bottom, the log, and then press Control C. Yeah, that should just. Yeah. Cool. Let's get rid of it. So all the stuff you want to write in the document should be inside the document environment. So this was all just an example. If you do want to put your stuff in bold, you put it inside the document. Yeah. As long as there's a way to compile the PDF. Probably that kind of PDF. Oh, yeah. Anyone else? We all have our first document up and running. Cool. So this is a pretty simple, kind of boring document, right? It's just text. So let's go into some of the cooler stuff. If you want to force a line break, you can't just press enter because LaTeX will ignore what's called line breaks. If you want to create a new paragraph, I'm just going to put in a bunch of gibberish. If I press a line break here, LaTeX will not recognize it. If you want to start a new paragraph, it's 2 line breaks. So my code looks like this, but once I compile it, we'll see it as a comparison. Let's go ahead and get rid of this. Notice that there's no double line break in the document itself. A double line break in your code equals a new paragraph on your PDF. If you want to keep adding line breaks, one thing you can do is double backslash. So this is a line. Double backslash after your line will create a new line break. This is another line. And you can keep stacking them. So for example, 4 will create 2 line breaks. 6 will create 3 line breaks. So we compile, Control-Shift-P. It's lagging. And there we go. This is kind of how LaTeX reads line breaks. So you'll notice one thing here. When I typed this is a line, it indented it because it thought it was a new paragraph. If I add a new line break by using the double backslash, LaTeX will not recognize it as a new paragraph. If you want to indent, there are commands you can do. I think the command is indent. Pretty simple. If you don't want to indent something, the command is no indent, and you put it before the thing you don't want indented. In addition to paragraphs, there's creating text in bold, which we already learned. This text will be in backslash text BF curly braces bold. For italics, backslash text IT. And then there's other cool ones. Typewriter text, this text will be in TEXT TT. And then inside your curly braces, whatever thing you want, typewriter text. So for example, if I wanted to put down my email address, I would put it in there. And it would, once you see how it compiles, it looks like this nice serif typewriter looking text. Yep, we all good? So I can keep throwing these different commands at you, but it's easy to look at this online. You know how to make a command now. you know how to make things bold, you know how to make things italics. If you want, for example, make something underlined, I actually don't remember how to make it underlined, but you could easily look it up online, LaTeX underline commands, and it'll probably tell you. So for those of you who are familiar with programming, there's stuff you can do before your document, because it's kind of weird that your document itself is an environment, right? So the reason it's structured like this is because there are certain packages that you can kind of install in your document that makes you do cool things. So if I wanted to do math in my document, before my document starts, before this environment, and after my document class, I'll put in a command. And this command is use package, /use package, and then whatever the name of the package is. If I want to use math, a really helpful package is AMS math. And again, for those of you who have programmed, like, I don't know, in C++ or something, this is kind of familiar to, kind of similar to importing a package, right? In C++, I think it's called include. It's the same thing. If you want some more functionality to your code, you look at these packages that are online and you sort of use them in your document. And there are a bunch of other packages that you can include before you start, depending on what you want to do. So our code as a whole is organized into two big sections. There's the document itself, where all the content is. Some people might call this the body, which makes sense. It's the body of your document, right? All the stuff that happens before your document, none of this is actually going to be printed, right? It's not going to print that I'm using this math package. This is called the preamble of your code. And if you look this up online, some people might refer to your code as, look at your preamble, make sure all your packages are spelled correctly. Or look at your body, make sure you've typed everything correctly. And so sometimes you might hear me refer to the preamble, the section before your document, or the body, which is the document itself. Just some little terminology. So in your preamble, go ahead and use package AMS math. Has everyone typed that in? And that will allow us to use this math package that lets us type in some math. So let's say we want to write an equation, because typesetting math is one of the things that LaTeX really excels at. I don't know, area of a circle is to type math, what's called inline, on the same line as your text, surround your equation in $signs. And when you're typing in math, if there's any special equations, any Greek letters like pi, epsilon, sigma, you can look up the command online, but chances are it'll be backslash and then whatever the name of the thing is. So \pi will draw the letter pi. If I do capital P, it'll draw capital pi in Greek, but I want lowercase pi. So the area of a circle is actually A equals pi. To make something squared, put in the caret, shift 6, and then whatever you want there. But it's not pi squared, right? It's pi r squared. So let's see. The area of a circle is A equals \pi and then r squared. Let's go ahead and compile that, see if it works. And there we go. We have a nice, pretty looking equation. Inline. One of the things I spoke about line breaks. LaTeX also ignores white space. If you have a single space between your words, then it'll just think of it as a space. If you have a bunch of spaces, it'll ignore that, and things will just look exactly the same still. And this helps in math mode as well, because if you have a very complex equation you need to spread things out, it might help for your own readability to spread certain things out. I'll just go ahead and compile this, and you'll see it should look pretty much the same. I mean, it should look exactly the same once it's done compiling. See? Looks exactly the same. So LaTeX ignores white space. Press space as much as you want, as long as it helps you read your code easier. So that's inline math. Sometimes when you're writing your document and there's a really important equation that you want to emphasize, you want that equation to be on its own line. So the command for that, it's actually an environment. So how do we write environments? \begin. And the environment is called equation. And then somewhere else put end equation. Backslash begin, and then equation in the curly braces. And then later on, backslash end, and then equation in the curly braces.
So equation's like a unique name for LaTeX?
What was that?
Equation has like an identity in LaTeX. You can't call it like equation circle and then.
That comes later, yeah. So you mean naming your own equations?
Yeah.
Yeah, that's another function, and that is important, but it's not part of the environment.
Equation's built into LaTeX, that word, I guess.
Yes.
Okay.
So equation is the name of an environment, a specific name of an environment.
Yeah, that's what I was trying
Yeah,
to write.
got it. So yeah, you have to type begin equation. Everyone got this? So if I want to put that on its own, I'm just going to use the same thing. A equals pi r squared. So we go ahead and compile this. Do we all have this working? So you'll notice when you put the equation on its own line, LaTeX does something different. It's not in line. It's not on the same line as your text. It puts it on its own line. There's some space before and after. It's centered, and LaTeX actually gives it its own number. And what's cool is let's say I'm just typing in some text here, and I want to put in another equation. Begin equation, end equation. And I'm going to put, I don't know, 1 plus 1 equals 2. So I have two equations. Everyone caught up? Yeah, actually this is a good time. Let's take a short break. Okay, so we all have two equations down, right? So you'll notice LaTeX has numbered these equations for me. The area of a circle, equation 1. 1 plus 1 equals 2. It's been called equation 2. I didn't tell it to number it for me. It automatically numbered it for me. So in that sense, I don't have to keep track of which equation is which number. I can just keep adding equations, and LaTeX will number them for me. And this is sort of the beginning of how LaTeX does some really awesome things for you. So when you write an equation, you might want to reference it later in your text, right? You might want to say, equation 1 shows us the area of a circle. So let's look at how to do that. In front of your equation, there's a command called label. And this is a name, a special name that you yourself give to your equation. It helps if you make it, something that's easy for you to remember, something that explains the equation. I'm going to go ahead and call it area of circle. This will not print into the document. It's just a name that I've given this equation.
How do you insert comments?
That's right. Good question. So if you want to comment anything, the symbol for comment is %. So it's good practice to comment things. For example, I don't know, %. This is equation for the area of a circle. For those of you who are not too familiar with programming, a comment is basically something that is for you to read in the code. It won't be shown in the document, but it's very helpful to comment most of your code so that when you look at it later on, or if someone else looks at it, they can understand what's going on. But yeah, to comment things, it's %.
Can you have spaces for labels?
I've never tried it, actually. Well, we'll see in a bit. I've always just kept them as one word. I think of them as variables, and with variables in a language, you can't really put spaces. But you could, I'm not sure. So I've labeled this equation area of circle. If I want to reference it later, let's say in the next sentence, I would say equation, and the command is \ref. That's how you reference something inside your document. So if I type in ref, for those of you on WinEdit, this is a nifty little feature. Once you type in ref and in the curly braces, it'll list all the labels that you've given. And in this case, I've only labeled one thing, so I'm going to go ahead and click that. Insert. There we go. If you're not in WinEdit, you could just type in whatever label you gave. I labeled this thing area of circle, so later on I'm going to say ref area of circle. We all have this? So, if you've labeled your equation and you reference it later on, once you compile, we'll see here, I have the area of a circle, and then I wrote in, or the compiler created this sentence, equation 1 tells us the area of a circle. And that's pretty cool, right? I didn't say equation 1, I said equation whatever this thing is. And then LaTeX will fill that in for me. It's called this thing equation 1, so it's going to call this thing equation 1. And that's where LaTeX is pretty cool, because say I have this equation, and I don't know, I put it way back here. I might have to compile 2 or 3 times. Whenever you switch things around, compile 2 or 3 times. So when I switch the order of these equations, LaTeX will switch the number for me, right? This is now equation 1, this is now equation 2. In my reference in the text, it's also switched this. Equation 2 tells us the area of a circle. And that gets really helpful when you have 30 or 40 equations and figures and tables on your paper. So a very powerful thing about LaTeX. In addition to single line equations, sometimes you might want to show your work on something, or you might want to list a bunch of equations. There is another environment for that called align. Begin, align, end, align. So let's go ahead and put some equation here. So if I want to put 2 equations on the same, well, or put 2 equations right next to each other, I'm going to type in my first equation. And we learned about line breaks, right? So after your first equation, add a line break. That's 2 backslashes. And then type in whatever you want your second equation to be. And you can, of course, label, whoops. Oh, I already typed this in, right? So let's put in something else. I don't know. Got it? Does this make sense? So we put in an equation. We've labeled it. The labels are optional, by the way. If you don't see yourself referencing the equation later on, you don't have to put the label in. After we put in our equation, we make a line break, 2 backslashes. On the next line, we put in our next equation. And all of this happens inside our align environment. So I'm going to go ahead and wait a bit until everyone has two equations. You can add more if you want. If you compile, you should get something like this. Pretty nice. 2 equations on their own line. You can keep adding them. Now, if these 2 equations were related, if I were showing some work between them, like, I don't know, moving a variable to another side, then it might help if these were lined up, like if I wanted the equal signs to be lined up. So in the align environment, what I can do is add the ampersand, Shift 7. And if you add the ampersand behind whatever character you want to align, this environment will align them for you. Most of the time, you want your equations to be aligned based off of their equal sign, so I'm going to put an ampersand behind the equal sign. Not always the case. Sometimes you might want to align based off of something else. You can move the ampersand anywhere else. But in this case, we have ampersands behind the equal signs. If we compile, there we go. They're aligned based off of their equal sign. And of course, LaTeX has given them all numbers.
Why are the equations in italics and then the 1 plus 1 equals 2 is not?
Oh, that's just a traditional way of writing math. I mean, numbers are not written in italics, but variables, letters are usually written in italics. If you don't want things to be written in italics, inside your equation mode, you can type text rm and then whatever text you want here. So technically, this is seen as another equation. It's written in normal text. It's labeled it. LaTeX has labeled it 5. But yeah, out of tradition, numbers are usually written normally. And if you're writing an equation, LaTeX will assume that any text you're writing is going to be a variable, so it'll write in italics for you. So as a general, I guess, typesetting etiquette, if you're not going to reference an equation later on in your text, you probably don't want to number it, because there's no use to have an equation labeled number 5, and you're never going to say equation 5 later on. It might confuse your reader, who knows. So if you're not going to label something, let's say I don't want this equation to be numbered. After the equation, I can add the command no number. We compile that. LaTeX has taken away the number. And I could do it for some equation in the middle. It'll take this number away, and it'll shift all the numbers around for you. Pretty cool. So those are the basics of math. We can go into some more complex things. So I'm going to show you guys how to create a more complex equation, just for practice. That looks good. Well, I'm going to show you some of the basics needed to create this equation, and then I'm going to have you guys create it. So let's make a new equation. Begin equation and equation. By the way, if you're wondering, a line allows you to put in multiple equations, and in the equation environment, you can only have one. If you wanted, you could use a line and just put in one equation. It would totally be fine too. You could use a line for every single, on its own line equation. I just tend to use equation for single equations, just for consistency. But let's look at this heat equation. So there's some things here. There's partial, and there's fractions, and there's big parentheses. There's Greek letters. So let's go over some of the basics. If I want to create a fraction, the command for that is frac, \frac. And frac is special because you have two arguments, right? Your numerator and your denominator. So you have to have two sets of curly braces. For those of you who are kind of new to programming, this is how I like to program. Whenever I type in a command, I will immediately put in the curly brackets, just so that I remember they're automatically open, they're automatically closed, I just fill them in. It's just a personal thing. If you're new to programming, or if you're familiar with programming, you might have seen this, where you have like a million parentheses. You have to keep track of which one's open, which one's closed. What I like to do is I type in a command like text BF, immediately left bracket, right bracket, and then type in whatever I want in there. So in the case of frac, type in \frac and then two sets of curly braces. In the top is your numerator. So I don't know, put in whatever you want. And the bottom is your denominator. So if you go ahead and compile that, you get a nice little fraction. Do we all have fractions working? Cool. This little d tells us this is a partial derivative, right? So the command for that is simply partial. \partial. Whoops. Let's say partial u over partial t. By the way, Does this look familiar? Or does this text look familiar? Every equation that's written in LaTeX, or written in Wikipedia, is done in LaTeX. So of course, chances are you've seen LaTeX before. If you want to write math in Wikipedia, everything's done in LaTeX. So anyway, if I compile this, it should look exactly like this term. And it does. Partial u over partial t. Great. There's other things. Alpha. Remember, if you want to put in a Greek letter, chances are it's just backslash into the name of the Greek letter. So alpha is backslash alpha. Simple. Parentheses, that's another big thing. So if I just have, technically I could just put a left parentheses here and then a right parentheses, and this will enclose my fraction in parentheses, right? But LaTeX, once you compile that, it doesn't look the best. Those parentheses are kind of small. So if you want to auto-size these parentheses, you have to turn the each parenthesis into its own command. So it might look a little hard to read. Let me add some space here. But I have backslash left parenthesis, my fraction, then another backslash, and then a right to close it off. So if I compile that, LaTeX is giving me trouble. Oh, I'm sorry. I forgot something. You want to put in left and then right. Yeah, there we go. So let me full screen this so it looks a little easier. Backslash left and then the left parentheses, and then backslash right in the right parentheses. And then LaTeX will kind of look at your equation and it'll automatically size those parentheses so that it looks correct. So left parentheses, my fraction, or my partial derivative, close off with parentheses, and then an alpha after that. So I compile this. Not bad, we got some progress. We have big parentheses, this partial derivative, and then an alpha. So now that you know how to do this, I want you guys to create this equation. We'll take another break. So you compile, you end up with a heat equation. Awesome. So that's equations in a nutshell. If you want to learn how to write other things like limits and integrals and other cool things, you can look it up online, or summations. You can find the documentation online. And this is kind of what I'm talking about when I mean getting over that initial difficulty hump, right? You all know how to write equations. You all know how to use commands and environments. Now learning the rest just means looking it up online and then figuring out what the commands are, what the name of each command is. But yeah, writing limits and integrals and summations, they're not too hard once you know how to do this stuff. So let's go away from math for a bit and learn how to add pictures, because pictures are important too, right? We have figures. To insert figures into your document, go back to your preamble. There's another package that we want to use. So in your preamble, backslash use package, and then inside the curly braces, I think it's called graphic X. Let me go ahead and check that. Yeah, graphic X. Do we all have that in at our preamble? So somewhere in our document, the environment to create a figure is, guess what it is? Figure. Begin, figure, and then end, figure. So inside figure, you're going to have a bunch of stuff that creates your figure. Much like creating a loop, like a for loop inside programming, I like to indent so that your code is a little bit easier. So it helps to center your figure. The command for that is centering. If you don't do this, your figure will be justified to the left. On a new line, the command to actually add your figure is include graphics. So backslash include graphics. And then inside the curly braces, you put in the name of your figure. So let's go on the internet and find a picture of something. I don't know. Ducks. Whenever you found a picture, save it in the same folder as your LaTeX document. That just makes it a lot easier. So once you've all found a figure, download a picture, go ahead and raise your hand. Once you put it in the folder, the same folder as your LaTeX document, it helps to rename it to something simple. I just renamed mine ducks. For those of you who are still looking, I'm just going to go ahead and type in the commands. They're easy to follow along. So inside the braces, you want the name of your figure, right? Mine is called ducks. I think it's called JPG. I think it's a JPEG. If yours is a PNG or something else, if you don't know what the extension is, you can just put in the name and it'll look for a picture that matches that. And that should be good enough. Go ahead and compile. There's a duck.
Can you go back? Gotcha.
Yes. Yes. Because it's the raw picture was really big, so I'm going to go over how to resize your picture later on. It might be too big. Yeah, it's too big. Once it's resized, it'll look more centered. I'll go over how to resize. Do we all have a picture inside our document?
Because I want to be able to like save this after class at this time and save somewhere. I don't
Is it saved on the desktop though?
It's on the
You know
desktop.
what's saved. Okay.
And I have text, so.
Okay.
But I can't. What's wrong with my?
It's the error. Missing the end document. Oh, you put the figure before your
Oh,
document. All right, do we all have a figure in our document? So some of you have had various problems. If the figure that you got from the internet was really big, LaTeX will just paste that in and it'll be really big, right? Some of you, if you're unlucky, you try to put the figure here, and then LaTeX won't listen to you and it'll put it at the top of the document. And that's kind of some of the quirks of LaTeX, that it thinks it's trying to do things that it knows better than you, and we can try and fix it if we think we know better. So if we want to resize this figure, I mentioned commands and arguments, but there's also options. Let me just go into some white space here and show you guys. So /command, your argument goes inside, right? Some commands have special arguments, like if you want to change the size of something. Argument goes before the curly braces, and it's in square brackets. Square brackets, whatever options you have. That's just how it generally looks. So include graphics is our command. Whoops. Our argument is our picture, ducks.jpg. One option we can put in is how big it is. You can put scale. So this scales it based off of its normal size. Scale equals 0.5. We'll scale it down to half of its size. One thing I really like is I believe you can do width equals whatever you want. 2 centimeters, 2 inches, 2 millimeters. 2 ems, which is a unit, a typographical unit. You can set width to, I think it's called \column width, but don't compile that or else it might not work. And that's pretty helpful because it'll set the width of your picture to whatever the width of your column is, or column width divided by 2 or whatever. Let's just say I want the width of mine to be 2 centimeters. So that is an option. Our command, followed by the option in square brackets, followed by the argument itself. Let me go ahead and erase that. So let's compile. Now it's 2 centimeters. All right. And now we've run into something else. LaTeX has moved this picture to the top of the document. This is probably because I chose this document class to be an article. And if you look at most journal articles, it's kind of a trend that their figures are at the top of the document, right? So LaTeX thinks I'm trying to write a journal article. It'll follow that sort of guideline by putting my figure at the top. If I want them to ignore that, there is an option to the figure itself. And I know I just said options go before, but in the case of an environment, it goes after. So one thing I can type is H, which means put the figure here. So hopefully if that works, the picture should go after the text. Here is a figure. And it works.
Well, what does that H do again?
It tells you put the figure here. So put the figure after this text. Because before it was putting the figure at the top of my page. Sometimes it won't listen to you still. If this picture was a lot bigger, then LaTeX wouldn't put the picture here. It might still put it at the top. So you can kind of elevate your privileges by typing in capital H. That means really put it here. And if it's just impossible to put it there, like the picture's too big, LaTeX won't listen to you. You can put an exclamation mark, which means I'm not kidding, put it here. Like this is actually how it works. Sometimes it will literally be impossible to put the picture there, so LaTeX won't listen to you. And in that case, LaTeX is probably right because you're probably trying to fit a figure into a spot that won't fit it. But
How do you put 2 figures
next to each other with subfigures? I'm not going to cover that, but look up Wikibooks. The command itself is actually called subfigure. So if you look up on Google LaTeX subfigure, chances are it'll tell you send you to the LaTeX Wikibooks, which is a great reference for learning new things that you want to do. Look for subfigure. And it'll give you an example of how to do it. Now that you know how to put figures in your documents, it should be relatively straightforward to follow this example and put your own subfigures in. You'll notice in this case, you actually have to use another package, subfig. It's just something that happens when you want to add subfigures. And in
Is the capital H? Like I actually have them at the top. I use capital H, it puts it at the bottom. I use lowercase h, it puts it where I want it.
oh, that's odd.
It's like the inverse, like the little h, like it's like here,
They could be telling you different things too. This has to do with floats, which is a whole nother subject that I'm not going to cover. Chances are, play around with H, capital H, or exclamation marks. We can see here, lowercase h, place the float here, approximately same location. Capital H is supposed to be put it precisely here. So ideally, it's supposed to mean, it's supposed to override lowercase h. And the exclamation mark means override that everything LaTeX thinks is good and try and put it there.
I think the thing is it's missing the package for float.
Ah, that might be it, yeah. Good eye. So if you want to use capital H, you want to import, use package float at the beginning, at your preamble. Yep. Any other questions? Okay, so now we have our figure. There are other attributes that we might want to add to it. If you have a figure in your paper, whether it's a journal article or, I don't know, a senior design report, chances are you want to caption it, right? So on the next line, backslash, caption, and then inside the curly braces, put whatever caption you want. This is a duck. It's actually a lot of ducks. And just like how you can label equations, don't use that. You also want to label your figure with some personal name that you give it. I'm just going to call it duck picture. So that later on in my document, if I want to reference this, then I can say the figure seen in, and I'll reference duck picture, and it'll put in the number for me. Yes?
Can you put a space between duck pictures? No.
I haven't tried that.
Actually, it didn't matter for the other one.
It didn't work? Okay, so yeah, I guess you can put spaces in your labels, and it should work. Thanks. So 4 recommended things for your figure. You really just need include graphics. But centering puts it in the center, caption gives it a caption, label is a personal name that you give it in case you want to reference it later. Let's go ahead and compile this. These computers are slow. There we go. So once I give it a caption, it'll automatically put in figure 1 behind my caption. And that's how it actually labels it for you, right? Because it wouldn't just put in figure 1 straight. If you just want to say figure 1, I think you can just put in caption and then nothing inside the curly braces. But it's good etiquette to actually caption your figures. So this is called figure 1. And just like the equations, you can imagine if I add new figures, it'll call them figure 2, figure 3. If I shift them around, it'll number them for me. And again, if I want to reference it, figure, I use ref, backslash ref, and then whatever name I've given it, duck picture. Shows us a sea of ducks. Some of you may have noticed that when you first reference something and you compile it, the PDF might not work. The numbers might be a little wrong. So it helps when you're shifting numbers, when you're shifting figures and equations around to compile it 2 or 3 times. LaTeX might need 2 or 3 passes to make sure all the numbers are correct. Luckily, compiling is pretty fast, so it doesn't really hurt to compile 2 or 3 times in a row. So there we go. I have figure 1, and I've referenced it. Figure 1 shows us a sea of ducks. And you've noticed when I typed in ref, this is a feature of WinEdit, but it tells me everything I've referenced so far, right? There are certain IDEs, as these are called, programs that help you type your code. And some of them will make a list of every label that you've given to everything. So it helps you organize every single equation that I've made, every figure that I've put in. And I know what these things are. Just from looking at these, I know this equation is the area of a circle. I know this is a duck picture. I know this is the equation for energy of light. So kind of like good etiquette in programming, you want to have good etiquette in LaTeX typesetting. Make sure your labels are all something easily understandable. Make sure you reference anything that you've labeled, and so on. So that's the basics of pictures. Oh, there are also links. Remember, we saw those earlier, right? If we see equation 3, we can click on the 3, and it'll send us to that location in the PDF. So to do that, there's another package we want to use. So go to your preamble, hyperref. It's called a hyperref. And actually, once you import that package, that should be it. It'll automatically make all the links for you. If you do not have this package installed, then what LaTeX will do is it'll download the package from the internet for you. So it looks like this thing might not have hyperref installed. There. Is this not working for anyone?
Can you go to the code again?
Oh, yeah. So in the beginning, use package hyperref. Let's take another walk around. All right. So we have the hyperref package installed, right? And some of you may have noticed, once you use the hyperref package, it does link to your stuff. I click on equation 2, and it takes me to 2. Click on figure 1, it takes me to figure 1. But it makes these red boxes around it, which is kind of weird. I don't know, it's something I don't like. So if you actually look up the hyperref package online, the idea is, some guy made hyperref, and so there's documentation online to learn how this package works. And hyperref itself comes with some options, right? There should be an option to get rid of that box and color your text, which is something I like better. Well, I'm just going to go ahead and skip the searching. If you look around at the documentation online, you'll find that the option is called color links. And so later on, if you find a cool package that does something cool that you want to do, like subfig, you want to make subfigures and you want to play around with it, look up subfig online. Chances are Wikibooks might have it. It'll tell you all the various options you can do to play around with it. So I've learned that color links is the option I want to do to hyperref to get rid of those ugly boxes. So remember, go to your preamble. Options go before the curly braces. And they're in square brackets. And the option I want to change is something called color links. And I want to set that to true. Again, this isn't something you have to memorize. It's all online. Not only that, now that you've spent all the time writing this document, you can just send it to yourself later on and use it for your future documents. Copying and pasting, so you don't have to write everything from scratch, just like code. So now that I've changed that option, set color links to true, it looks, in my opinion, better. It doesn't have those red boxes, and it just colors them for me. Click on it, takes me to equation 2. Click on this, takes me to figure 1. Finally, I'm going to go over 2 more things, and they're 2 as you can tell, LaTeX is kind of, I guess I would call it modular. It's flexible. You can add new things, new equations and figures, and it'll shift around the numbers for you. You don't have to worry about changing things yourself. And that not only applies to text inside your document, but also things outside your document. So one thing I'm going to show you is how to, I'll show you a bibliography first. Because you're going to have in a nutshell, you're going to have another file that shows your bibliography with all your citations, everything you want, your authors, your titles. And then you're going to reference that file inside your document. And when you change that file later on, your LaTeX document will automatically look at that file and incorporate the changes. You'll see what I mean once we start it. So let's actually make a brand new document. And this will be our bibliography document.
Can you just do a new begin document command in the same file? Or will it make two PDFs if you do a new?
I've never actually tried doing begin and end and then begin and end again. Yeah. I wouldn't recommend it for the bibliography though, because the bibliography is technically a completely different thing. It's not even a document. Let me go ahead and load something on here first. Can I save as a bib? Awesome. So we made this new file. Save it in the same folder as your LaTeX document. Name it whatever you want. I'm going to name it my bib. And then save as type. Don't choose tech. Choose bibtech. Bibtech is kind of like a special version of LaTeX made for bibliographies. And I like the separation because that means all my sources are on its own file. If I'm searching around the internet and I find a cool paper, I can just throw it in here. And then later on, if I want to reference it, I can look through that file that I've made to cite it. So call it my bib, save as type bibtech, save it in the same folder as your LaTeX document. Everyone have that? So let's say I want to source an article. Let's look for a big name article. Yes, cells. In biomedical engineering, and I guess in biology, there's this idea of induced pluripotent stem cells, which are cells that are not stem cells, but they act just like stem cells. Anyway, this is a really big paper, and I want to cite this because it's like a game-changing paper. So I go to this, and I have all the information I need, right? I have the journal name, the volume, the issue. If I want to start a citation entry, it works like this: at article, and then a curly bracket, and then add some spaces. And then whatever you put after your first curly bracket is going to be, it's kind of like your name, your label. So for me, I'm going to call it, when was this published? 2006. I'm going to call mine Yamanaka 2006. And I think a bunch of other LaTeX people kind of follow this as well. You don't have to, but it's a good thing to maybe name it after the last PI or the first author in the year it was published. So I've called mine Yamanaka 2006. When we're citing an article, what are some things that we want to put in bibliography? The title of the article, right? What else? Authors. Date, journal. Issue, yeah, and pages. That's pretty much all that's important. So on each line, put a comma after your label. On each line, you're going to put in the thing and then comma. So let's do title. Title equals, and then put the title in quotes. So whatever cool article you found online, just grab the title and put it right in here. And then put a comma afterward. What else is there? Journal. Again, journal equals the name of the journal. This journal is called Cell. All the big name journals are like one word: Cell, Nature, Science, Nano, Small. Year. What year was it? 2006. You see the pattern, right? Year equals quotes 2006 and then a comma after each new line. Volume 126 and issue 4. By the way, I spelled volume wrong. Notice how it's not color-coded? It's a nice little safety net. In case you do something wrong, you might notice that this is not colored correctly. Once I spell it correctly, it's the same turquoise as everything else. Issue, I just forgot what. 4. Yeah, issue is not highlighted, but I'm pretty sure that's correct. And then pages. 663 to 676. And on the last line, don't add a comma because there's nothing else. I've organized it like this for readability. Remember, LaTeX doesn't care about white space. If I totally wanted, I could write my entry like this. It's just harder to read, right? So this is our bibliography. Now, there are programs that will do this stuff for you. And in fact, some article websites will actually allow you to export a citation into BibTeX. So it'll fill all of this stuff for you already. But it's good to write it down the first time just so that you know what to put in. So now that we have this entry in our bibliography file, we want to cite it in our document itself. Do we have to import anything? No. So let's say I want to create a bibliography at the end. There's a command called new page, which creates a brand new page. It's just a good idea to put your citations, your bibliography on a brand new page. Bibliography, that's a command. And then inside the argument, whatever you called your bibliography. I called mine my bib. Before bibliography, there's another command called bibliography style, because there's a lot of different ways. Ooh. Because there's a lot of different ways to create a bibliography, right? There's MLA, APA. I like IEEE. I use it a lot. So under bibliography style, IEEETR. There are other styles. I actually don't remember what they are, but they're all listed online if you want to use them. IEEE is the one I use the most personally. And this should be good enough. Let's just try compiling it. Oh, you know what? So it's now read my bibliography file, but it's not going to do anything because I haven't actually cited this. So remember, in my bibliography file, I called this thing Yamanaka 2006, right? So if I want to cite it, it's just like ref, except not ref. It's called cite. And this is another nifty thing about WinEdit. Your editor, if you don't have WinEdit, it might do this, it might not. Depends on what you're using. In this case, it recognizes that I'm trying to cite something, and it says, oh, hey, you have something called Yamanaka, so it's going to add in here. And when you cite something, let's say in IEEE style, it's going to be at the end of your sentence, right? So I might say, IPS cells were published in 2006, and it has been game-changing. And the citation usually comes at the end of your sentence and before the period. So I've cited Yamanaka 2006, which is this entry that I've created in my bibliography file. Does anyone have any problems? Anyone need time catching up? I know it was a lot of stuff to do.
Yeah, I'm having a problem with IEEE.
Sure. What's up? All right, so 5 minutes left. Let's just wrap up from here. So there was one other thing I was going to show, but we don't really have time. I think there was a lot of demand for a MATLAB workshop, right? So you might find sometimes that if you create your code, it doesn't have to be MATLAB. If you create your MATLAB code or C++ or Python or whatever, you might find sometimes in your document you want to import your code into that document, maybe as an appendix or something, so that people who's reading your essay can see what your code is. And real quick, you don't have to follow along, but there's a package for that called listings. And anywhere in your article, you can put lst input listing, list input listing. And in there, you put, I don't know, my MATLAB file .m. And what it will do is it'll take the code inside that MATLAB file and it'll paste it there. And that itself is pretty cool because if you want to have an appendix with all your code, you just create this link in a way to your code. And LaTeX will automatically grab all the code from there and paste it in, even as you update your code. So just another little thing that I haven't covered. Yep. Yeah.
Does that simply display the code in the document?
Yes.
And formats it?
Yes. And bolds and color codes, and there's various options to the listings thing. You can like put line numbers and put it in a box, stuff like that.
Okay.
Yeah. So it's a very nice little package. And in general, I mean, there are a bunch of other cool packages that you can look up if you want to figure out how to do it, like subfigures, for example. So hopefully I've gotten you past that big initial hump. You all know how to do you all know how to use LaTeX now. You know how to import packages. You know how to create commands and environments, pictures, figures, bibliographies. You guys all get that email about the LaTeX workshop? There was a link to a website hosted on my domain where it gives you instructions on installing LaTeX on your own computer if you want, various resources. There's my email. Feel free to email me if you have any questions, installing, debugging, whatever. I'll be happy to answer. I made some templates that you can use if you want to use them for homework or write essays. These are the examples that I covered. And if you don't have this website, you can either write it down now or I'll grab all your emails later and I'll just send you a link to this URL. If you have any questions, feel free to email me. And thanks for coming, guys.